What makes an ion engine so much more efficient than a normal rocket engine? Any rocket engine creates thrust using Newton's famous third law of motion. For every action, there's an equal and opposite reaction. A chemical rocket burns rocket fuel and shoots rocket exhaust out the engine's nozzle at roughly 7,000 miles per hour. The weight of the exhaust, combined with that speed, is what generates the thrust. You could create a much more efficient engine if you could shoot things out the nozzle at a higher velocity. That's the basic idea behind an ion engine used on spacecraft like Deep Space One. Instead of using combustion to accelerate the atoms, an ion engine accelerates them electronically. The first step is to take xenon atoms and ionize them to give them an electrical charge. A pair of grids charged to over 1,000 volts accelerates those xenon atoms to 77,000 miles per hour. Because they're traveling 10 times faster, each atom leaving an ion engine provides about 10 times the thrust of the atoms leaving a chemical engine. To charge the grids, most ion engines currently use solar panels to provide electricity. The panels on Deep Space One produce 2,400 watts. That's enough to accelerate about 100 grams of xenon atoms per day. By providing a small amount of thrust over the course of a year or two, ion engines can accelerate spacecraft to very high speeds.